Hello friends, welcome to our site Quadratic Academy, and today in this presentation we are going to solve an example under common roots of quadratic equation. So given that if the equations x square minus 6x plus 5 is equal to 0 and x square minus 12x plus p is equal to 0 have a common root, then we have to find the value of p. So in our previous video we have learned the condition for the two quadratic expressions to have a common root is given by c1a2 minus a1c2 whole square is equal to a1b2 minus a2b1 into b1c2 minus b2c1. So if we substitute the values over here, we can find the value of p. And there is another method to find the value of p. So now let me explain this concept by solving the equations with another method. So first we write the given equations. We have the first equation as x square minus 6x plus 5 is equal to 0. Now let us name this as equation 1. And then we have x square minus 12x plus p is equal to 0. So this is our equation 2. So given that two equations have the common root, that means the roots of the equation 1 would be the roots of the equation 2. So first let us find the roots of the equation 1. So the equation 1 is here, x square minus 6x plus 5 is equal to 0. So we can find the roots of this equation by the factorization method. So on factorizing this, we get x square minus 5x minus x plus 5 is equal to 0. Now taking x as a common factor over here, we get x into x minus 5, and again by taking minus 1 as a common factor, we get minus 1 into x minus 5 is equal to 0. So this we can write as x minus 5 into x minus 1 is equal to 0. So we get here x minus 5 is equal to 0 or x minus 1 is equal to 0. So therefore we get the values of x as 5 or 1. So as mentioned that equation 1 and equation 2 have the common roots, these roots would be also the roots of the equation 2. So we can say that 5 and 1 are the roots of the equation 2. So let us write over here the second equation, which is x square minus 12x plus p is equal to 0. So first let us substitute the value of x is equal to 5 in this equation. Then we get here 5 whole square minus 12 into 5 plus p is equal to 0. And here by simplifying this we get 25 minus 12 into 5, which would be 60 plus p is equal to 0. That implies we get here minus 35 plus p is equal to 0, and therefore we get the value of p as 35. And then we have the another case where we have the value of x is equal to 1. Now let us substitute this in the equation. So we get 1 whole square minus 12 into 1 plus p is equal to 0. That implies we get 1 minus 12 plus p is equal to 0. And we get here minus 11 plus p is equal to 0. So therefore we get the value of p as 11. So we get two different values of p, which is 35 and 11. So this is how we solve an example under common root of quadratic expressions. Hope you understood the concept. For more videos, visit our website Quadratic Academy. Thanks for watching. Have a nice day.